Oftentimes, when you're doing trig equations, you're going to find a question which looks something like this, where you have cos squared, you have sine, and then you have sine squared, or some sort of combination of sine squared, cos squared, sine, and cos, maybe even tan. Now, in this scenario, you're going to be expected to use your identities. You're going to be expected to use what you know about equations and different types of equations to solve it. Now, if I've got a something squared, so an unknown squared, and then I've got an unknown on its own, what type of format am I going to be expected to use? Quadratic. That equation can be turned into a quadratic. Can you try it? See if you can figure it out. So in this case, you've got sine squared, and then you've got cos squared. This cos squared is the thing that's messing everything up, right? If it were a sine squared, it would make things easier. So you want to change this into something that includes sine squared. The way you do that is by using the identity. Sine squared plus cos squared is 1. So if we rearrange for cos squared, we get 1 minus sine squared. And now we can substitute that in. Like this. When you expand and simplify and move everything to one side, you get this. And there you go, that's your quadratic. When you factorize, you get this. And now you can solve for each bracket. You would do each one separately. So in the case of the x equals 2, this would give you no solution. No solution. Because sine x has a maximum of 1. In the other case, we're going to substitute that, or we're going to solve for that. So sine minus 1 of minus 1 over 5. Sine minus 1 of minus 1 over 5. And we get minus 11.54 degrees. In this case, it says the interval is from minus 180 to 180. Right, from here, we're going to use the cast diagram. But we're going to use the cast diagram in a slightly different way to how I've done it before in the previous videos. We know that the points are labeled as such, and now we're going to go and draw the line for minus 11.5. If it were positive, like we've done before, we would draw a line here and label this as 11.5, right? But in this case, it's minus, which means we're going to go the opposite way. Minus 11.54 degrees. We said when it's positive and it's sine, it reflects this way. When it's negative, it's just going to be a mirror image. So it's going to reflect that way, where this is also minus 11.54 degrees. Okay. The question says the interval is from minus 180 to 180. So we're going to draw our arrows, but we're going to do them in two separate directions. One direction is going to be clockwise, the other one is going to be anti-clockwise. Usually we go anti-clockwise in the positive direction. We can also go minus 180, so the negative direction. So this is one solution. So x can equal minus 11.54, and this is the other solution, which we would get by doing minus 180 minus 11.54, and we get minus 168.46 degrees. 168.46 degrees. Sorry, it's a little cramped. Okay, if we go in the positive direction, we would start from 0 and we would make our way round. But in this case, that doesn't work. Reason being that our limit is 180. Positive. That red arrow goes past 180. So our two solutions are minus 11.54 and minus 168.46. Okay, I hope that made sense. But that's essentially what you're going to do. You are first going to solve, then you're going to use your cast diagram to work out all the solutions. Okay, so have a look at this question for me, and I want you to give that one a shot. Okay, so first off, we've got sine squared and then we've got cos. If we want it to be in a quadratic, we want to change that sine squared into a cos squared. So we use the identity and find a substitute for sine squared. Like that. And now we sub that back in. Like this. And now you expand, you simplify, you do what you need to do. And you reach that step. After factorizing, you get this bracket and this bracket. And when you solve, these are your two solutions. Cool. Cos x equals a half gives you x equals 60 degrees. This gives you x equals 75.5 degrees. You're going to do the cast diagram separately. You're going to do one for this, one for that. 0, 360, 90, 180, 270. Same on the other side. 180, 90. Okay, let's start with 75.5. That's 75.5 degrees. It's cos, so it's going to reflect that way. This is also 75.5 degrees. We go anti-clockwise, like this. That's one solution. And all this is the other solution, which we get by doing 360 minus 75.5, which gives 284.5. So that's that one done. The other one, 60 degrees. That's 60 degrees. It's still cos. That's also going to be 60 degrees. This is solution 1. And that's solution 2, which you get by doing 360 minus 60, 300 degrees. So for x, you have 4 solutions: 60 degrees, 75.5 degrees, 284.5 degrees, and 300. There you go. That is how you do the harder trig equations.